Today's lecture we will discuss another type of reflector antenna, that is parabolic reflector antenna. Okay, parabolic reflector antenna. So this is an example of a practical parabolic antenna. So this comes under why this antenna is called as parabolic reflector antenna, because here whatever this reflector, so this is the reflector. This entire structure is a reflector. This is the shape of the reflector is in parabolic. The shape of the reflector is in parabolic. So since the shape of the parabolic reflector is in parabolic, we call this reflector as parabolic reflector. Parabolic reflector. Parabolic reflector antenna. Okay. So to improve, why you are going for parabolic reflector? Okay, why you are going for parabolic reflector antennas? Okay. So to improve the overall radiation characteristics of the reflector antenna, to improve the overall characteristics of reflector antennas, the parabolic structure is often used. The most popularly used reflector is parabolic structure. So basically a parabola is a locus of a point which moves in such a way that the distance of the point from the fixed point called focus plus the distance from the straight line called directrix is constant. Okay. So here the fixed point, focus point, and the directrix is constant. Okay, let us see what is meant by directrix, what is meant by. So see here, a type of reflector which has the reflecting surface in the shape of paraboloid. Okay, in the shape of paraboloid. Okay, so what is the main purpose of this parabolic antenna? The main purpose of this reflector is to collect or transmit the electromagnetic energy. Collect or transmit the electromagnetic energy. So it is the simplest form of the reflector antenna. Okay, so this is used for microwave. So this is known as microwave, means it will operate for microwave frequencies. Okay, microwave frequencies. Okay, so this is parabolic reflector. So this is parabolic. So since the shape of the reflector is parabola, the shape of the reflector is parabola, we are calling this as parabolic reflector. Okay, this is called as directrix. This is the opening. Okay, so this is our primary antenna. So what it will do, from the primary antenna, rays will fall on the reflector. Rays will fall on the reflector, and all the rays will comes out of the directrix. This is the opening of the paraboloid. The opening of the paraboloid, we call it as aperture, or we call it as directrix. Okay, so this is directrix. Okay, so here the time taken for a signal to, for example, let us take the path F M M dash. F M dash is same as F N dash. F N dash. Similarly, same as F P dash. Okay, means all the signals are leaving the director same time. Okay, so if you observe here, all the waves are traveling in same direction. This is called as plane wave. This is called as plane wavefront. Okay, so here the shape of the reflector is parabola. Here this is the active antenna. So from the active antenna, the first the rays falls on the parabolic reflector. Then it will reflects this, and all the rays will move in a plane wave, means in same direction. Okay, so by using this parabolic reflector, we will get high gain. Okay, so this is the geometry of parabolic reflector. It just comes to this parabolic reflector transmitting. So transmitting end means you are using the parabolic reflector both for transmitting antenna and as well as receiving. For example, what is the best example of transmitting parabolic antenna? For example, if any live coverage is want to do in TV, okay, then whatever the antennas like this antennas, this is nothing but parabolic antenna. So this is used for transmitting the radio waves. Okay, transmitting the waves. Okay, what is the best example of receiving antenna? What is the best example of receiving antenna? In our house top, we want to get the signals for our DTH antenna is there. Okay, that is the best example of receiving antenna. That is the best example of receiving antenna. So what is going to happen in the transmitting antenna? So here primary antenna is there. From this the rays are radiated like this. They first fall on the parabolic reflector. On the parabolic reflector, all the rays will move in same direction. Okay, so you get plane wavefront. Okay, so this is in the case of transmitting antenna. What about receiving antenna? Different rays are coming here like this. They will fall on the reflector. They will fall on the reflector. So what the reflector will do? It will send all that points to the focus point. Now this is connected to your TV or anything. Okay, so this is a receiving antenna. This is receiving antenna. This is transmitting parabolic reflector. This is transmitting parabolic reflector. Okay, this is transmitting. This is transmitting one, transmitting parabolic reflector antenna. This is receiving parabolic reflector antenna. Okay, so I have already told what are the various forms of feeding techniques for any reflector. Various forms of feeding techniques. So one is using, so this is a parabolic reflector. One is using, you can use the primary antenna. Here the primary antenna for any reflector antennas may be one horn antenna, or it may be a group of dipoles, or it is a single dipole, Okay, so these are the different types. These are the different types where you have the primary antenna. Primary antenna means what is the primary antenna? Which excites the reflector. Which excites the reflector is called as primary antenna. Okay, so for any parabolic, we'll keep the primary antenna here. For example, this is my primary antenna. On this primary antenna, it will send the signals on the reflector. Once the signals falls on the reflector, all the waves will travel in same direction. This is nothing but this forming of this is nothing but plane wave. This is plane wave front. So these are the various